Here we go with our first set of notes in our Evolution in Animals unit. This one we're going to just outline what it means to be an animal and some of the characteristics we look at when we're organizing animals. First off, the defining characteristics of animals are these four things. They have to be multicellular, they have to be able to move, they have to be heterotrophic, which again is the opposite of autotrophic, meaning they have to eat their own food, and then all animals undergo sexual reproduction. They may not do all this stuff all the time. Some animals may only move when they're larvae, for example, or some may only reproduce sexually at certain points in time, but they do that at some point in their life cycle. The first major characteristic that we use in defining organisms is symmetry. You probably recall from math class, symmetry being when you're the same on both sides, like if you could fold something in half and it matches up perfectly. In biology, we tend to use symmetry a little bit more generally. It doesn't have to be absolutely perfect, more like body plan, like a silhouette, for example, and I'll talk about that a little bit. But first off, there's the most basic, which is called asymmetrical or asymmetry, meaning you're without symmetry. And you can see that, for example, in this guy over here. There's no way that you can divide this guy in half and get two equal halves. It's not going to happen. There's just no symmetry to this organism. The second type is called radial symmetry, where there's multiple lines of symmetry. So, for example, this jellyfish exhibits radial symmetry. You can see that there are multiple ways of dividing this guy in half and getting basically the same thing. Now again, like I said, it's not perfect. There might be one extra little hairy cilia-like thing on one side or the other, but overall we would say that this jellyfish has radial symmetry. Just think of like radius is something you see in a part of a circle, and usually circular organisms are going to have radial symmetry. And then finally, there's bilateral symmetry. Bilateral literally means two sides, and so there's only one line of symmetry. You can only get two equal sides. So these are things that there's just one way you can divide them in half, just down the middle. Obviously, you couldn't divide this guy and get two equal halves there, or you couldn't be slightly off center because they would be very, very different. So this guy has bilateral symmetry. The next characteristic you would use to classify an organism would be the organism's tissue layers. Organisms can have up to 3 different tissue layers. The first layer that you would see would be something called the endoderm, which is always going to be the innermost layer. Endo means inside. And this usually gives rise to digestive system and some other organ systems. Next, some organisms might also feature a mesoderm, which is a middle layer. This is going to form lots of different types of muscle. This is the layer that's also going to help divide the body up into lots of different compartments or sections. And finally, there can be the ectoderm, or outer layer. Again, ecto being outside, derm being skin or layer. And this usually forms, obviously, the skin, and then the nervous system often comes from the ectoderm layers. And you can see down here in this diagram of earthworm how it's got 3 different layers. The yellow layer being the endoderm, forming the digestive system. This pink being the mesoderm, forming the tissue lining and forming the body cavity, helping divide that body up, and then the body covering being created by the ectoderm. 2 other characteristics we use to classify organisms is their type of skeleton and then their segmentation. And the type of skeleton, which I'm pretty sure you're familiar with, that being an invertebrate, something that does not have a backbone, or vertebrates, organisms that do have a backbone. It should be said that you don't necessarily have to have a backbone to still have a skeleton, right? Think of, for example, a crab. They have an exoskeleton, so they have an external skeleton, but they do not have a backbone, so they're invertebrates. When it comes to segmentation, it can be a little bit trickier. There can be no segmentation, so the organism is clearly not divided at all, or the body can be divided up into repeating units, something you might think of when you think of segmentation, or just separate areas. We, for example, show segmentation because our bodies are divided up into different areas. You've got your digestive organ cavity, you've got your cardiovascular cavity, your nervous system is separated from everything else. All your different systems are in like different separate areas within inside your body. So we actually have segmentation, even though we're not made out of repeating units. Since we're talking about body cavities and body areas, we should probably define what that is. This is another major characteristic used in classifying organisms. And in this context, we call the body cavity a coelom, kind of a funny word. And there's three different options in body cavities. You could be an acoelomate. Remember, A means without. So these are organisms that have no body cavity. So if you look at this guy, this planaria cut in half, he's got this internal section that's basically his digestive system, which is more or less open to the outside, if you think about it. And then in here, everything is solid. You just have solid mesoderm, no body cavity at all. The second option in body cavities is something called a pseudocoelomate, so this means false body cavity, and this one is a little bit trickier. Basically, you still have a body cavity, so if you look over here, there is an empty space on the inside, it's totally on the inside of the organism, but in this case, it's not totally surrounded by endoderm. It's partially surrounded by mesoderm and partially surrounded by endoderm. And then finally we have the true coelomate. These guys have a true body cavity, and basically what makes it a true body cavity is that all bits of the body cavity are totally surrounded by mesoderm. So most higher organisms are going to be true coelomates with the body cavity totally surrounded by mesoderm. And with that, we are done with this set of notes.